Watch this animation where a conducting loop of wire is rotated inside a magnetic field. Now, the ends of the loops are connected to two rings. If you notice, this end is connected to this ring, and this is connected to this ring. Now, notice that for one full rotation of the loop, the direction of the induced EMF changes. Now tell me, when do we have maximum induced EMF? Look at the meter here that measures the induced EMF, and also look at the graphical representation of the induced EMF. Now, when the loop is like this, it is cutting the lines of force at right angles, you have the maximum there. Now, watch when the loop comes, say, like this. The loop is parallel to the lines, there is no induced EMF. And when it begins to move up, the direction changes. So, watch again, when do we have the maximum and when do we have zero? Maximum in the opposite direction, zero, maximum, zero, and so on. So when the loop is parallel to the field, the loop is not cutting any lines of force, therefore there is no induced EMF now. Now they're cutting at right angles and the maximum EMF exists. Now as the loop moves down, it begins to cut more lines of force. Alright? The EMF decreases to zero, now increases, then decreases to zero, and increases, and so on. Now, the output is taken across these two rings, and the output is an alternating EMF, as you can see in the graph and also in the meter. Now tell me, what change would you make in this arrangement, especially of the rings, so that the output will not be alternating, but it will be in the same direction? Now, write down your answer, draw a diagram, and also draw a graphical representation of what the output you expect to look like. Now, I can actually speed up the animation, and you can see how rotating it faster increases the amplitude of the induced EMF. In other words, when you rotate the loop faster, the rate at which the flux linked with the loop changes is more, and the induced EMF is more. Why? Because the induced EMF is directly proportional to the rate of change of flux. Is that right? Okay.